Hi, welcome to Section R3 of College Algebra. This is your instructor, Bethany Sansing-Helton. So we're going to review solving linear equations and inequalities in this section. And these are the objectives that we'll be covering. So there's a general process to solve linear equations that most of us follow. And the steps, you can break it into 6 steps. And that is, if you have an equation with fractions, it's to first clear the fractions. And there's a couple of different ways to do this. And then distribute and combine like terms. If necessary in the equation, use properties of equality to get all the variables on one side and all of the non-variables on the other side of the equal sign. Combine like terms on each side of the equal sign. Get the variable all by itself with just a coefficient if there is one, and then finally to divide through by the coefficient of the variable. When you're all done, there is step 6, which is to go back and check your work. A lot of people skip this step, and it's pretty critical to go ahead and do it. So I'm going to do an example for you with fractions so you can see how to do the process that involves clearing fractions and distributing. And I'll write it over here under the example. So I have 2/3 times m plus 6, and that's equal to negative 1/2. So I want to clear the fractions, and one of the ways to do this is to figure out the least common denominator of the entire equation. Since I have a 3 on the left as the denominator and a 2 on the right, my least common denominator is 3 times 2, which is 6. So I'm going to take my entire equation, and I'm going to change my pen color so you can see what I'm doing here, and I will multiply through by 6. So that means I'm going to take my entire equation and I'm going to multiply the whole thing by 6. You can also write it as 6 over 1 if that helps you. So when I do that, that means I distribute it to every term. Now there's only one term on each side, so I'm going to multiply 6 over 1 times 2 over 3. So when I do that, I actually divide. I say 3 goes into 6 how many times? Twice. So the 3 becomes a 1, and then the 6 becomes a 2, and so I end up with 2 times 2, so I get 4 for the left-hand side, m plus 6, and then I also need to multiply the negative 1/2 by 6 over 1, and I do the same thing. 2 goes into 6 3 times, so this equals negative 3. That's step 1. Step 2 is to distribute. So I distribute the 4 into the parentheses. I get 4m plus 24 is equal to negative 3. Step 3 is to use the properties of equality to get the numbers on the other side. So properties of equality say if I subtract something from one side of the equation, as long as I do the same thing to the other side, then my equation stays balanced. So I subtract 24 from both sides of the equation. I get 4m equals negative 27. Finally, I divide both sides of the equation by 4 to get the m all by itself. So m ends up being not a pretty number. It's negative 27 over 4. I'm going to leave it an improper fraction. Don't change it to a decimal. Don't change it to a mixed number. Just leave it that way. The final step is to check it in your calculator. And all you do is you plug in the negative 27 over 4 into the original equation in your calculator and verify that the left-hand side truly is negative 1/2, which it is. So let's go through some special cases. One of them is what happens if you're solving an equation and the variable cancels out. So for example, what if I have the equation shown right here, 2 parentheses x minus 4 equals 2x minus 8. Well, if I were to just go ahead and solve this, my first step would be to distribute. So after I distribute, if I wasn't necessarily paying that much attention, and I said, okay, well, I want to get the variable all by itself on one side of the equal sign, so I'm going to go ahead and subtract 2x from both sides. Well, when we do that, 2x minus 2x ends up being 0. So I get negative 8 equals negative 8. It completely cancels out. No more variable. But this is true. Negative 8 does equal negative 8. So when this happens, what this tells us is it doesn't matter what we pick for x. No matter what we pick for x, it will always work. The equation will always be true. So this solution has a name. It's called an identity solution. Doesn't matter what the variable is, the result is always true. So we want to write this using set or interval notation, and I'll do a little review on set notation in a minute. So in set notation, I would read this as the set of all x such that, this line here means such that x is an element of the reals. Or we could use interval notation, and in interval notation I say that x is an element. This x is an element part is really shows up in the book all the time, but not so much in Alex. But this little e means is an element of, and then I say it goes from negative infinity to positive infinity, meaning x can be anything. Now, the next option is what happens if I solve it and I get a false statement. So this is true. Negative 8 equals negative 8 is true. But instead, if I have 2x minus 4 equals 2x, when I distribute the 2x, I get 2x minus 8 equals 2x. And again, if I subtract 2x from both sides, I get negative 8 equals 0. So when negative 8 equals 0, that's false. That will never be true. So what that tells us is that now again, the variable completely cancels out. If you get 2x equals 0, then that's x equals 0. That's an answer. That's a solution. But if the variables completely cancel out, you get negative 8 equals 0, no more variables. That will never be true. That's called a contradiction. And that means that you have something that no matter what the variable is, it will always be false. So the solution for this particular equation is nothing. Nothing will work in it. So you can write in set notation brackets with nothing in them, and that is the symbol for the empty set. Or you can use in interval notation, you can use the 0 with the slash through it, and that's null, the null symbol. Either one of those represents a contradiction. Nothing will work. Okay, so a quick notation review. Set notation, anytime you have inequality symbols, we're using set notation. Really, the important stuff about set notation are these curly brackets. And then basically what we're saying here, this first part, x such that, says, so here's my variable, and this part after the line is the rule for the variable. So the rule for x is that it has to be between 1 and 5. It can't equal 1, it can equal 5. So in words, I would say the set of all x such that x is greater than 1 and less than or equal to 5. You can write that same thing in interval notation. Now notice interval notation is much more compact. So interval notation says that x is between 1 and 5. The parentheses is less than or greater than, and the square bracket is when it's also got the equal to piece of it. So here it is greater than 1 and less than or equal to 5, just like the one above it. They match. Again, in words, x is an element of the set that goes from 1 to 5. So, and then a couple of notes on symbols. That little e that you saw on the previous slide means is an element of. Again, you'll see that a lot in the textbook, but not so much in Alex. And then you have this upside down U. That is an intersection. Intersection is that, and it goes with the word and. So whenever you might think that and or are not very important words, but actually they are critical, and goes with this U, and a lot of times we remember that because if you draw a little line inside of it, it looks like an A. So the U is and. The upside down U is and. Now, the one that looks like a U goes with the word or, and that is a union. And a lot of times we remember that the U goes with union because the first letter of the word union is a U. So a couple more examples. Again, these two match. So remember the word or, this is a very critical word. You cannot just ignore this joining word, this conjunction. So here I have x is less than -3 or x is greater than or equal to 2. So if it's less than a number, that means it goes from -infinity to that number. So in interval notation, it would go from -infinity to -3. And then the word or is the union symbol. And it goes from 2, since it's greater than or equal to 2, that's why we have the square bracket, starts at 2 and goes to positive infinity because it could be anything greater than 2, so it goes all the way up to positive infinity. You always use parentheses with positive and negative infinity. Always, always, always. Okay, so solving compound inequalities. I have an example on this slide to show you. It's just like solving equations, except when you multiply or divide both sides of the inequality by a negative number, you have to flip the inequality symbol. And it's really important to check back in the original inequality that you did things correctly. Now, you could see compound inequalities written as 1, and when they're written as 1, it's always an intersection. It's got an implied and, which means it's only between the numbers that you get as an answer, or it's an empty set. And then if it's or it can be written out separately using the word and or. So you really got to watch out for the word. So here's an example of an intersection where it's written out as 1, and there's two different ways to solve this. You could solve it all as one thing, or you could split it up. I'm going to split it up just to show how to do it this way. This is more general, and you're less likely to get into trouble if you split it up. So when you split it up, you solve two separate inequalities. First, I solve the one on the left. So -7 is less than -3/4 x minus 1. So the first thing I'll do is I'll add 1 to both sides. And so I get -6 is less than -3/4 x. And then I'm going to change my pen color. So I want to clear my fractions, and I'm going to clear the fractions by multiplying by the reciprocal of the coefficient of x. So I'm going to multiply by -4/3 on both sides of the inequality. Still have to do the negative because I want the coefficient of x to be 1. So -3/4 times -4/3 is 1. That works. So I get x on the right hand side. Now I'm multiplying by a negative number, so I have to flip my inequality symbol. So that goes from a less than to a greater than symbol. And then I divide. 3 goes into 6 twice, and I get -4 times -2 is +8. So that's the first one. Let me change my pointer back to blue, and then we'll do the second one. So for the second one, I start with the stuff in the center. So I have -3/4 x minus 1, and that's less than or equal to 11. And then I solve that one. So I add 1 to both sides. I get -3/4 x is less than or equal to 12, and then I repeat. So notice I'm repeating. This is why you can actually solve it all at one time, but I'm not really showing you that method here because you're prone to errors with that. If you want to go ahead and solve it at once, if you're comfortable with that, then by all means do it. Okay, so this time again I'm doing the same thing. I'm multiplying by the reciprocal, so I get x all by itself, and it's oops, I have to flip this. So let me go to the eraser, and then let's go back to my pen. So since I multiply by a negative, I flip it, so it's greater than or equal to, and then I divide. 3 goes into 12 4 times, and 4 times 4 is negative 16. Now we can write our answer all as one thing also. It needs to be, see how the smaller numbers on the left and the larger numbers on the right. So we have to do the same thing here. So I write the negative 16 on the left. If I switch places, if I switch the places of negative 16 and x, that's fine as long as I also flip the inequality to go with it. So x is greater than or equal to negative 16, or negative 16 is less than or equal to x, and that makes x also less than 8. So this is the solution to my compound inequality. If you wrote it 8 is greater than x is greater than or equal to negative 16, I would mark that wrong. It is not valid to write it in that form. It must be smaller number on the left, larger number on the right. So you can write it. You can write your answer in 3 ways. This is let me turn our solution into interval notation by erasing the box, and then I'll show you the easy way to switch it into into set notation. So to write our answer in set notation, remember set notation has these inequality symbols, and so if I want to turn it into set notation, I simply add the line with the x and the such that, and I put the curly brackets around my inequality. So this is set notation. Interval notation, I go and I say, okay, my first number is negative 16, my second number is 8. Since x is, since it's less than or equal to, the equal to part tells me it's a square bracket, and since it's just less than 8, it's a parentheses. So that's interval notation there, and then graphing it on the number line. I'm assuming you all know how to do that, and there's not space here for that. Okay, so now we're on to our applications. So first let's do just direct translation. If you read this problem, we see that we're looking at someone that's on a diet. He's abandoned his diet. He's consumed 13 calories more than twice the number of normal calories. If he consumed 416 calories, what is the normal amount? Okay, so first thing, notice that it says more than here. This is not an inequality. More than is addition. If it said is more than, that is greater than. Okay, so be very careful. More than is addition, is more than is greater than. Okay, so we underlined our key pieces of the problem. The question, how many are normally allotted? That's what we want to find. Now we want to define our variable, and the question helps us. I'm going to let C be the normally allotted number of calories. And so I go back up here to this 13 calories more than twice the number of normal calories, and I write that out. 13 more than, so 13 plus twice the number, 2C, and that is equal to how many calories he consumed, 1,467. So then I go ahead and I solve that problem. I subtract 13 from both sides. I get 2C equals 1454. I divide both sides by 2. I get C equals, my pen's not working. What happened? C equals 727. So that's it. 720 calories are normally allotted. You want to make sure you write your answer in words with units. Okay, one final application here for you is an inequality application. So Jacques is going to college. So this is from the textbook. On an academic scholarship, he needs to maintain at least a 75% average. That's what tells us it's an inequality. At least, at most, is less than, all those things. So far he scored an 82%, a 76%, a 65%, and a 71% on 4 exams, and we want to know how much he has to score on his last exam to keep his scholarship. So, what's the problem asking for? The minimum score he can get on his last exam. So how do I know it's an inequality problem? Again, it's got the word at least. So we define our variable again. So I want the x to be the last exam score. And then how do I figure out what the average is? Well, I know average means add all the scores together and divide by the number of scores. He's got 4 scores already. If I add in the last exam score, I would have to divide by 5 scores. So I take all 4 scores that I already know and x, and I divide all of them by 5, and that score has to be at least, which means greater than or equal to 75. And then you go ahead and solve that problem. I'd like you to do that one on your own. This is not that complicated, and you can ask me in class if you got it right. We're running short on time here. This is already 22 minutes, so I'm going to go ahead and stop. This is the end of section R3.